All right, next up we've got Jeff Wagner. Hey, Jeff.
Hi, guys. Hi, Chris.
So for the two or three people that don't know you, maybe you could give us a little background on yourself.
Yeah, I'm senior technical consultant at Side Effects. I troubleshoot Houdini. I deal with customers. I'm always looking for new ideas and sharing everything and anything that I know about Houdini. Yeah, and it's exciting to be able to do what I'm doing today. Thank you, Chris, for inviting me.
Excellent. Well, give us a little rundown on what you're going to talk about in your presentation.
I've got this tradition of covering what are the TD features inside of Houdini 18.5 or in previous releases, and I want to cover that for Houdini 18.5, looking at all of those features that are relevant to TDs and TAs. And Houdini 18.5 has got more features than any previous release I've ever looked at, relevant to expert users who are very familiar with Houdini. So hopefully this is a quick tour of all of those features, spanning everything from the new Python states, Python handles and drawables, all the way through to SOPs and compile SOPs. We always have to cover that, and everything in between.
Excellent. Well, let's get started.
Great. Would love to. Thank you. Let's go.
Hi, my name is Jeff Wagner. For the next little while, we're going to be taking a look at Houdini 18.5, focusing on what I think are the top features that are under the radar and looking at some of the technology behind some of the features that we have inside of Houdini 18.5. 18.5 is a massive release with a lot of features that were added that didn't make the top reels and the top keynote, but are very significant to Houdini users as they progress and use Houdini 18.5. So this is just an interesting overview of what I think are the top features that we should all know about. And for today, just a little bit of the background on the specifications of Houdini and the system running on. I'm working with Houdini's Gold build version 18.5.351, and it's the Python 3.7.1 release. My machine is an Intel Core i9-10900X CPU, dual CPU running at 3.7 gigahertz, and I have 64 gigs of RAM, and the graphics card is a GeForce 2080 Ti. So the first thing we want to take a look at is some dopamine hits that we want to get right out of the way. So first we want to take a look at my first three. The Pyro Minimal Solver, and it's all on the GPU. The second one, my second top, is Vellum Paint. I'm sure you've seen lots of demos, and I know that there's going to be other Hive presentations on the simulation framework, but I want to take a little bit of a look at the architecture behind it and the choices we made when we developed these tools. And finally, a little bit of polish on the UX and networks. So let's dive into Houdini and see what we can do. So inside of Houdini 18.5.351, we can see that in the technical desktop, we always get the Python shell. And we can clearly see that I've downloaded the Python 3 build 3.7.4. And yeah, let's go. So the first thing we want to do is take a look at Pyro. And we offer three different ways to enter Pyro now. Two I'll show you right now. One of them is from the shelf. And so this was in 18.0, but we expanded upon them with real production presets for 18.5. And we've reworked the material as well. So we have two Pyro shaders now, one that gives you the existing workflow we had in previous releases, plus a new one that we have in 18.5. So let's start off with a sparse fireball, place it in our scene. And that builds the traditional workflow that we're familiar with if we're using the shelf tools all at the object level. And I've obviously hit play. We can see that we now get our fireball in our viewport set up with all the presets. And we'll just quickly inspect the anatomy of this particular tool before we actually go and do this all inside of SOPs. Playback's pretty good. And let's go back up to the object level. I like navigating via the tree view. It's very quick to move around. And sure enough, there's our geometry, and then there's our dynamic simulation. Diving inside of our fireball object will give us the workflow where we have a power burst source, which is all new for Houdini 18.5. It gives you one source location for building all of your initial geometry. If we move our display flag to that and we press forward, you can see that it's using this new workflow where we're spitting out points, not a particle system, but points. It's an implicit system that was designed to just give us a really nice starting framework for our pyro simulations. And if we control middle on that, we can see that we've redone all the fields as well, and all the data that gets fed into the pyro. We got burn, burst ID, CD. But it's basically burn now has taken over heat, fuel, and everything else. And there's p-scale, which is the particle size, which is actually gets turned into the volume rasterized to build our volumes. Source name and temperature. So burn, temperature, and velocity are the key elements in the new pyro solver. And if we take a look at the volume rasterized attributes, move our display flag down to here. Here we can see we have our volumes. And again, control middle on that shows you that we have burn, density, and temperature, and velocity. You can add divergence. There are ways to add divergence down here. You can add more fields as you work, but everything is pretty nice and available for you here. You can even blur the velocity, which tends to diffuse the velocity, making things a lot softer. And you can actually blur the velocity over time for very, very fast moving volumes to sort of alleviate that issue that we always had with substepping. Blurring the velocity voxel over time tends to smear out the put-puts that we sometimes get in simulations. Now we round trip out into the pyro simulation, and then we come back in with the object merge. And there's our basically bringing in all of our fields, and then we put down the new pyro bake volume, which actually also has built into it all the shaders that we need to work with our pyro. So if we uncork this, right mouse on it and say allow editing of contents, we can dive inside of this. We can now see the basic framework of everything that's inside of this pyro simulation. Again, all in geometry. You can see that we have a whole bunch of reshaping of the VDB fields. And the part that I wanted to cover here is the material network. So inside of the mat net, we can see that we have the pyro shader. And so it supports the new workflow, taking in the fields that we have designed. We also spent a lot of time, I'm just going to tie that up again, match current definition. We also spent a lot of time matching the render look to the actual pyro look as well. And so we can demonstrate that. Let's go a bit further back. And let's add an output driver. I'm going to do Mantra for now. Render Mantra PBR. And let's now fire up a render pane in here. We can grab that and put that in there. There's no lights currently in my scene, so it'll just use the headlight. And we can see pretty close matches to what it is we're doing now. So trying to get address all those issues that we've had in the past dealing with working with pyro. And it's a low resolution that we're at right now, and all the other, you can see here, opacity samples need to be increased. We can do all of that. Standard workflows apply, so it's not that different when we actually get to the result, other than we have far fewer fields, much more efficient. So that's the first way we want to work. And the second way is if we just put down a SOP. So let's put down a geometry object. Let's call this fire. Dive inside, and we can now right mouse or tab the network view to actually get our list. And let's go to the pyro shelf tools now. We can see that we have a whole bunch of configure options in here, and these are fairly equivalent to shelf tools. But what they now do is actually add the entire setup right inside of the SOP context. So let's choose something a bit different. Let's do a power configure GPU, or let's actually do the ground explosion first of all. And that will actually build a network for us that will set up the anatomy of a pyro simulation that will actually do a ground burst fire in this particular case. And once it's complete, completely different setup now. And we're now entirely inside of SOPs. So if we then take a look at let's say, the initial start frame up here. We can press forward. We can see that there's the initial points that we want to work from. So in this case, we have 3 points in our scene that we want to work with. And I'm going to change my viewport to dark because that makes it look a lot lighter. And we can offset the start frame. And this allows us to shift the start time of our simulation, and then the pyro burst source, which is actually, again, what we use to generate the points from those initial seed points. And if, of course, if you offer more seed points, you're going to get more seed points. And again, control middle on that gives us the exact same thing: burn, temperature, and velocity. And in this case, we actually have a divergence field as well as there, and we're carrying density for smoke. So an additional 2 more fields that are key to what we need to feed this new pyro solver with. And of course, then we have the pyro solver ground explosion. So this is where you want to go when you really want to start studying the new pyro framework. You might be working in an existing studio that has your own pyro tools. You might have adapted them to Houdini 18.0's adaptive solver. That's great. But these tools are designed to show you a really great way to get a starting point for doing enterprise type simulations, for doing classic type sims. You lose none of the control, even though that we have minimal fields available to us inside of the pyro solver. You can actually dive inside of the solver and add your own microsolvers. For instance, you can dive inside of the microsolver here, and you can build your own microsolver framework. You can do any sort of advection. If you want to advect the fuel, you can actually introduce fuel, advect it, and as long as you export out a burn field out of this that will work within the slots that we have, it'll be great. Plus, you can carry your own fields for doing shading and rendering if you wanted to add some unique colors or other things. You had the full gas microsolvers available to you in here that you've always had before. A nice playground to work inside. Just be wary that if you do any work inside of here and you choose to use the minimal solve option inside of the pyro solver, right now it doesn't get used. There's only very few solvers that you could put in there that actually would work with if at all, work with the minimal solve. The minimal solve is mostly just straight ahead, but we're not using minimal solve here. It's still adaptive pyro. And again, all the same other framework. We also have again, the Pyro Bake Volume, which is our back-end tool for creating the fields for doing final rendering and applying the shader as well. So really nice way of working. Now, the other one I want to show is the GPU solve. Obviously, there's going to be a lot of other people covering this, but I just wanted to do a quick look at the actual, so let's do Pyro Configure GPU. If you do have a GPU that's worthy of doing these simulations, then definitely use the GPU. We're sort of saying that it has its role is to support the look development of particular pyro simulations, and it does work in a fixed container size, and because that's just the way that we have to present it to the GPU, and it's the way the solver is designed. And you can tweak this, and then of course you can always offload it to the to the CPU solve. But it's also very important to realize that this can actually go quite high depending on what direction you're going. Again, if you go to the Pyro Solver, the Advanced tab, that's where we actually have the minimal solve. Now, there's a bit of confusion here. We have the old Use OpenCL option available to us. That's to support existing 18.0 and previous workflows. It is by no means compatible with the minimum OpenCL solve. As a matter of fact, don't use this if you're using the minimum open solve. And of course, if you use the non-minimum open solve it now, you get your adaptive voxels and you can increase your resolution if you blow past your GPU memory. But there's the minimal OpenCL solve for you. One of the things that we've done is we can actually add collisions on here, and we've implemented nano VDB. So I'm going to just add, I'm going to do creating context option here. That means that I won't create a new object. And let's actually put down a sphere, and let's move the sphere up, and let's make it a bit bigger and place this in our scene so that it collides with the pyro, and it's good. Now I want to use this as a collision for my pyro solver, and so what we can do is we can turn this into a VDB grid using the VDB from polygons. So tab VDB from polygons, put that on the bottom of the sphere, and then we can wire that into the pyro solver. And again, playing forward, it's not really evident that the sphere is working with the simulation. So let's make it a bit bigger so we can actually see this, and play forward again. And now we can see that the pyro simulation is evolving around the collision sphere. And it's important to note that at this point in time, we actually have a VDB grid. And we can see we've got a lot more information available to us now as to what version of VDB we're using. So in case you're building against a custom version, it's all available to you. And but what's really interesting is once you go into the pyro solver, when we're using the minimal solve version, which is what we're doing, where everything's on the GPU, we actually lift that VDB grid into the nano VDB from NVIDIA's Omniverse, and the tool set that they have. We've been working with them very closely to support VDBs inside of Houdini. So we automatically move that VDB grid into the GPU. So everything is on the GPU at this point in time, straight from the solver into the viewport. And then you can start dialing in all of your different behaviors on the pyro simulation. So again, it's a really powerful tool. Now, there are ways to actually access these open VDB grids, these nano VDB grids in OpenCL, work with them directly. Definitely have a look at some of the files, and that might be in a subsequent masterclass, or we'll see if we can explore that even further, how to use these open VDBs in OpenCL directly in your OpenCL tool sets. But again, entirely all on the GPU, and it's just a matter of just going to that advanced set and just basically turn that OpenCL acceleration on or off. Now on to the next feature that I want to take a look at. Number 2 is the vellum solver, or the vellum brush solver, and we're going to start off with the pig head. And we're going to put down a solid conform. And this, but it no longer puts down a solid conform, it puts down a tet conform. So we've rejigged all of the solid type tools to rename into tets. So if we do a tet type, you can see that we have tet conform, tet embed, tet fracture, and tet partition. So all the solid tools, they're still there, but some of them have been deprecated. We'll talk a bit more about the new SOPs later on. But tet conform is the new tool for generating tets from your geometry. Now, as always, we need to put down, we have to put down the configure. So vellum configure, in this case, you do need to put a vellum configure on all the geometry. It's the barrier to entry to get into vellum sculpt. So let's put in tetrahedral soft body, and we can already see we put down the tet conform, but we can bypass that. And let's put the tetrahedral down there, and that actually builds our tets for us. And now we can change some of the properties in here if we so wish, but let's dive right into the vellum brush. So tab vellum brush, and we can wire them to the 3 inputs. By the way, if you do the vellum brush in the viewport, I found out that we only do the first link and you end up with an error, so it's probably best to add the vellum brush in the network. But anyway, so now we're ready to go. And let's make my interface a bit bigger here. Now there's a hotkeys on the bottom. Now remember, this is now viewport state, and we've completely rejigged the hotkeys. Just a word of warning. We can choose volume, surface, screen, nearest point, or connected geometry as the options, and they're all available to us on the top as well. We can do the visualization mode if we want to, but the really big one is all the brush options that we have available on the number keys 1, 2, 3, 4, 5, 6 to do all of the different options on there. And obviously we have F for freeze outside, G for settle, and then live for live simulation if you want to turn that on, if you want to actually work with it in simulation mode or not. Again, it's all exposed at the top. The very bottom, this particular state, which is new for 18.5, we can see here that to resize the brush, it's now Control-Shift-Left mouse button. So we left the middle mouse button available to do other things. So Control-Shift, make the brush a bit bigger, and there's going to be all kinds of different videos on what we can do with these particular brushes. I want to take a look at the vellum brush in terms of a flow when we actually have to run a simulation on a placed object. In this particular shot, let's say we need to start off based on directional control with this sort of a setup, and what we can do now is we can press this option on the vellum brush in the parameters reset state. And what that does is it basically resets the state, resets all the rest positions. So now we can take that pose as our start, and then we can put that into a vellum simulation node or vellum solver operator. And again, we can place that down. And now we can run our sim. Let's turn the ground plane on. Let's move it down a bit. Something like that, and then you press forward, and the simulation will start with some of the energy as it goes. Yeah, and again, you can tweak all kinds of options, and all the regular vellum solver workflows work within this architecture. Now I want to take a look at a couple other simulations that I've set up that show a little bit more of the workflow that we were talking about. So we have a basic grid, and pass it through the vellum cloth, configure it as cloth in this particular case, and then we do the vellum brush work on this. And again, we press the reset state, and then we can subdivide this to get more detail, and then we can apply second set of vellum cloth constraints. We can completely reconfigure it as cloth again, and then do another second vellum brush. In this case, we can tangle it up into a knot, and the inside versus outside. You can see that I used a lot of the middle mouse options to lock some of the points as I was twisting the knot, and then eventually put on a vellum post process to clean up some of the geometry. And again, if we wanted to simulate this, we could put this into a vellum solver SOP and do continued work to this. Another example is using a tube, again using the tet conform, and in this case adding some more vellum constraints, in this case tetrahedral stretch, and what this does is it tries to preserve the volume, and then another vellum brush. And you can see here that we can now literally work with this and tie this into a knot, pulling it into each other, and creating a simple knot. And then we can use the vellum post process to do more work on it, to basically render it a bit smoother and to add subdivisions. But again, nothing stopping us from adding more subdivisions and continuing on working further forward. And the vellum brush really is a stateless solver. You can dive inside of it and actually see the basics of what is just a vellum solver. But this state really does offer a lot of interesting workflows. So now we want to take a look at some of the new tools that we've provided in the actual network editor. And this is number 3. So if we always have the Y key for cutting links, but we've now added a J key where we can just simply stroke through the operators and it wires them together. You have to be a bit careful. As we can see here, the tube went into the wrong input. So if you sort of arc down that, it's pretty implicit as to where that it goes. And I'll show you when we're cutting 3 links, you can hold down again the J key and you can swipe to do the 3. So it's a bit quicker than doing click, 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 click. And another thing we added is new radial menus to the network. So if you hit the N key, N as in Nancy, you can now see that you get this full radial menu. And these are fully customizable. And let me show you where that is. So we just dive down. If we go under Edit, radial menus, up way in the upper left-hand corner, This gives us the new, well, it's already existing, but there's some really cool options that we have available to us. So we actually have the regular 3D scene viewer tools, and we can actually go to the network editor. And here we can see our radial menu. So if you wanted to change one of the behaviors on this radial menu, for instance, we want to do down, and in this particular case, it just says, just set the current new working directory as the child of whatever it is that I have currently selected as a node. But we can, I just have a script off screen that I can paste into here. In this case, if not is not type instance, go to the current node, if not dive down. So you can put whatever tools you want in here, and then when you hit the N key, you can execute any scripts you want, so it's fully customizable. We also added another type of a node, another type of a quick mark. So if we go to the 3D scene viewer, one good example is the insertion points tool that was added for Solaris LOPS, and that is a completely scripted way of generating a radial menu. So this is brand new, and you can create any one you want by either just duplicating that by hitting the D key, and then you can create your own version, or down in the lower right left hand corner you can actually say a regular menu or a scripted menu, and here you can actually start writing your own scripted radial menu. Again, insertion points is a great place to start to have a look at how to actually define your own radial menu as an example. And so pretty sophisticated workflows here. So great set of tools, a nice update to all the radial menus as well. Next on my list is release support. I can't think of a release that we've had that had more supporting material and more content files available upon the gold release. One of the areas that we did a great job was on the content library. You can see, I just took a snap from it yesterday. We can see all of the new tools and scene files that we added that were used to support the release material. We have the full Eric rig, really nice shotgun publisher tool in the PDG, some explosion examples that are brought to the point where you can do a final render. Also a lot of fabric presets that we were talking about in the release. Also a nice KineFX antenna vellum setup, KineFX jump rope, KineFX train adaption, the Sophia rig, which is actually an object level HDA, which we can use to import into the new rig tools or start animating right away in the Houdini 18 method way of doing animation, and a lot of other previous files that are of interest that are, so this basically is where we put all of the supporting content for a lot of the presentations that we have. I want to take a look at the Eric, basically the antenna vellum setup, just so you have a look at it in a bit. But some of the other things that need to be noted is we are shipping with Python 3.7.4 now. And unless you have a pressing need to run Python 2.7, definitely go and get the Python 3.7.4 builds, especially if you're an enthusiast and you've written some Python or not too much Python. You can definitely definitely start testing it for us and using it. I've had little to no issues running Python 3.7.4 in the gold release. And you got to note that it's way at the bottom of the download page. And everything is Python 3.7 except the inline CPP tool and the HQ tool that we ship with Houdini. Those are still written in Python 2. And for those that are using Python, you can take advantage of Future Package, which ships with Houdini. And you can use any of the suggested fixes from the Future Cheats sheet. So you can pause this screen and you can type in this link and get some information as to how you can utilize, the step from 2.7 to 3.7. And of course, I want to go through some preferences and take a little bit of a look at Labs. Labs is still rocking, and there's some really nice tools in Labs that we'll take a look at a little bit later. So let's dive in and take a look at that. So please download all the content on the content library. I'm actually going to open up some of those files. I have an assets directory with a whole bunch of different things, and I have an area for context library, and let's take a look at KineFX antenna vellum simulation. So double click on there, and there's a HIP file. I actually took this file and added some motion files to it, and I'll show you where that is. So this is a typical file that we might use. It's an education-based file. It's also requires always a little bit of work to get to work out, but in this case, there's a retarget node in here, and we'll notice diving inside of that, we actually have to download some mocap information. So you just follow the instructions, go and log into Mixamo, and if you've ever seen a lot of the different tools or a lot of the different animations you see in a lot of different videos, really fun videos, you can take a look at the various different sequences. And now with the new tools, all of these FBX animations can be brought in really easily to do and to motivate your characters. It's really a powerful tool set. So by doing that, you actually can learn all the new rigging tools that we have inside of 18.5. That's just an aside. What's most important is this file is now available for you to have a look at. And of course, you can take a look at the various different operators that are used to motivate this particular character. And as I said before, when we do all of this work, you can see here's our antenna workflow. You press play, there's no motion. We output the skin, the rest position, and then the deform pose. So it's intended that you know how to use the deform nodes. So if you if you go into here and you can actually go to the bone deform node, and it has all the 3 inputs. All the capture and skinning information came from the FBX rigs. And now once you do that, you can see that you can bind your motion to it. And yeah, really flexible, powerful solution. And again, there's your seam files, and then you can save this file out and move forward. So all the different files are available for us to work with all these different workflows. And the boring stuff. Definitely have to cover preferences, as I always do. There's some really interesting preferences, more to do with the lighting side of things. So this is all completely rejigged. We've renamed all the different states for doing working inside of LOPS. We can put a new primitive PAP for default authoring within the scene graph. Collections go put into collections. So if I, for instance, was working in environments, I could put in here environments collections, and new primitive path, I might want to put env/os. And that means that any primitives we create in Solaris will now, from this point on forward, will use these particular tools. So if we want to create environment lights, we can put them in a directory called env. So, and transform suffix, we can default it to $os. We can even preface that as well with, if you want, env as well. And that way, if you're an environment artist, everything you do inside of USD will now be in the end context. We can quickly see that once we press accept. And then we can go to Solaris, again, just looking at presets. And then you can just add a simple test geometry, the crag, and we can quickly light him. Every time you add an area light now, you can see that it gets put inside of env lights, area light, and test geometry crag will come in the way it normally does. But all the ancillary assets that you do for the preferences will show up. A couple other things with the preferences, handles, just a little bit more work on it to support the new handle workflow, and interactive tools, that hasn't changed. So the big changes inside the preferences are inside of lighting. Labs has also been busy. If you don't know or haven't installed the Labs tools, it's a must these days when you're dealing with Houdini. There's a whole bunch of tools for doing FX work, and what these are wrappers around common workflows on top of the Houdini architecture. So it makes it easier for you to do day-to-day work, especially when you're building mesh processing, building levels. A lot of the workflows that are tedious to redo, or you might have to do your assets, you can build all of these assets. And so the currency of almost all the lab tools are digital assets. So it's interesting to see that there's been some really nice improvements in Houdini in that area. If you go to the Vimeo Labs website, you'll notice that there's a video from Paul Ambrosian that was released about a month ago that actually has some of the new labs workflow around digital assets. And that's all in part about working with versioning digital assets, where you can create a subnet, right mouse on it, and you can have access to create version digital assets. You can give them a proper namespace, and you can see here you can build up a really nice namespace, prims, default, :1. And it's easy to build these namespaces and then create your new version digital asset. There's even tools that allow you to customize where those assets get placed. So you can actually define via the environments, side effects labs.json. You can even define what your VHDA path is, so you can have all your assets delivered to that specific location. You can also then, once you've created your version asset, you can actually easily increase the minor version or the major version very quickly. And this is intended to work with assets, because we've realized that many people will use the lab's assets and then they want to make a version of their very own. They don't want to open up the type property. So we finally have a really quick way of creating a minor version on top of an asset, and it'll bump the minor or the major version up. So we finally have a proper workflow to help you work with your digital assets. Again, always link into the Vimeo website and take a look what labs are up to. I'm going to fire up Houdini as well. And one of the other things that I'm using all the time is the crash recovery. And that also is a nice courtesy from labs. One of the things I want to say is, if you're using Solaris and the Hydra Delegate in 18.0, when the Hydra Delegate goes down, it would take down Houdini. And as an aside, in Houdini 18.5, we try to restart the server again before we bring Houdini down. So a lot of these insta crashes have been minimized a lot inside of Houdini 18.5. But definitely take out the labs. If you haven't installed it yet, there's some really nice tools. This one was from one of the internal TDs. SOP network. So let's add a sphere and dive inside. And one of the things done by Michael Buckley is the ruler tool. Really nice. It uses drawables in the Python viewport tool set that we have made available to you. And so he also recorded this, and it's available online. So labs, definitely a great place to go. Some really nice improvements for 18.5, including the pick and place tool. Please check that out. So next on the list is number 5, viewport features. We've done a lot of work on the viewport, adding fog and depth of field, and we've also added a lot of speed improvements into the Houdini GL, the GL Delegate as well, and a whole bunch of other features. So what we want to do is fire up Houdini, and I'll show you how the viewport fog features work. So here I have a simple scene set up. It's just got a simple height field, just a terrain height field, and we've got a camera and a point light looking in our scene. So we're going to set this to cam 1. To take a look at the fog options, you hit the D key in the viewport. You can turn on fog. And we have, very similar to what you would have in Unreal, we have the uniform fog. We can add a sun. And we can also add some volumetric fog, just this general depth volume fog to the scene as well. We're going to take a look at some of the uniform fog options we have here. We can control whether it's below the ground or above the ground. We can increase the density. Let's do no limit. And sometimes we have to sort of tweak the viewport to get it to evaluate. And let's take a look. And it's also the camera as well. If we go back to the camera, sometimes the far clipping plane on the camera is not suitable for the fog. So we notice here the far clipping plane. Let's draw that in, something a bit more reasonable. And now we can see that the fog is kicked in. And now that we're back into fog, we can say the uniform fog, we can adjust the density. 1 is usually a good place to start off with. We can go to 0.01. So then the opacity as well, we can control the opacity. Let's set the fog to 1 again, and we can set the opacity however we want. There's a depth range. We can actually do above the cloud strata or below the ground, and we want to do below the ground. And we can notice that this height is tied into our height field, and we don't really know where that is. So if we start raising this up, it would be nice if we actually had some nice user controls over all of this, and we can do that. There's this node override option here that we can use to actually control these fog settings. So and it doesn't matter whether it's Solaris or inside of the object context. Let's do it inside of the object context. I'm going to put down a null, and I'm going to call this fog control. And on here, we can actually do a node override. And right now, because there's no parameters on this, any parameters that I put on this fog to override this will actually work. And the way you do that is you can right mouse on the fog and you can go to the edit parameter interface on that particular operator. And if we go to node render properties, and you can see already it got the filter in there, but if we put the filter in there for fog, we can see that in viewport displays we have all of these fog options that are presented here in the parameters available for us to add to this node. So I just press the arrow to point to the right to add to this operator, and then I press accept. And now this fog object all of a sudden takes over. We can see that the node override is set to fog control. Now, because I'm actually, the sun is the only one that's not tied into here, we can see the OpenGL fog light options, fog light scattering, fog light intensity. We can increase or decrease the intensity of any lights in the scene casting through our fog, and that's via the sun. And then also the OpenGL fog params. So if I go here to uniform, now this is now taking over. For instance, if I change the fog color to red, you can see now that I'm controlling the color. Let's set it to a nice blue. And so now we're going to close this because now we have the node override set. We can do the fog depth range as well here. We can do the fog below the strata. Let's do some really nice ground fog. And we can see here we can adjust this. But what we really want to do is give a control to the viewport. So the control actually has a handle in the viewport. So we can take the transform in Y and do copy parameter. And then we can go over here and we can do paste relative reference into the fog height. Now as we increase this operator, you can see here, we can now control the height of our fog. And if we the fog height roll off, let's set that down to something a bit lower so we can create some nice ground fog here. And by adjusting the near and far clipping planes on your camera, you can sort of hold off the fog past the terrain. And we also have fog sun bloom. So if we actually had a light in the scene here, and let's cast a little bit of a warmish light on the scene. And we can see the exposure is already pretty high at 18. We can actually light the fog as well via these controls as well. So the fog sun plume and the fog intensity from the lights as well. So that's that. So this gives us a lot of localized control. We can have several of these operators in our scene. And inside of Solaris, it works quite well to add some fog to the Houdini GL viewport to see what it is that you're up to. One final option, as I said before, we do have volumetric fog as well, and you can control a lot of the quality settings on that option as well. So you can actually add some just broadband light scattering in your scene as well. And you can do above this, so you can have ground fog down below, and then you can have high volumetric fog on the top of your scene to control your scene. And of course, it's all lit. So really powerful tools with the fog, worthy of inclusion in this video. Now on to viewport state tools, number 6. Python viewport states are maturing quite a lot inside of Houdini 18.5, and we added something new, viewport state handles, and we've extended the drawables options as well in the viewport. Those are those things such as text and other decorations that you want to put in your tool. We've also done a lot of more work forward on that. And there's some of the tools that use that are, for instance, the polybevel and the labs box cutter SOP are using a lot of the new interactive Python states, as well as the measure SOP that we saw in the labs tool. And just to know that this is just the beginning for a viewport workflow. So let's fire up Houdini and have a look and see how we can access these and what's the way forward to learn how to create these tools. Now inside of Houdini, let's take a look at how a couple of these Python states and the handles actually work. I'm going to add the test geometry pig head, or the rubber toy, and dive inside. And we want to try the poly bevel out because we know that that got reworked for Houdini. So let's work a bit on the neck here. We want to add some edge loops on some primitive faces. So in here, let's do poly bevel. Select that, and now it's in the selection state, so we can actually select some polygons, and we got edges, points, or polygons. Let's choose polygons and use the A key to select a ribbon and then hit enter. Now we have a couple handles available to us. As you can see here, as we just simply do the left mouse button, we get a drawable on the screen, which is showing the distance, and we get a really nice indication as to what we're doing. And as well, the wheel will increase or decrease the number of divisions on our poly bevel. Really simple. If we right mouse on the handle tool on the left hand side, we can actually see the two handles that are currently bound to this particular tool, the distance. So we actually have two handles defined within Houdini, one called distance, one called divisions, and this particular tool is using those state handles in the viewport to do that. Really straightforward and easy to use. Now another one is the box cutter tool from the labs. So if you have labs installed in Houdini, you can do tab box cutter. And now with this particular tool, again, follow the state. All good tools should have a decent state. You can left click and drag on the geometry to create the cutting plane. Without letting go of the mouse, hold control and drag mouse to add depth. So let's try that. So we're going to actually draw in here, and then we're going to hold on the control key to drag up and down to create some depth. And when we're done, we just press A to stamp the shape and then draw another one. So it's working as advertised. And again, hold the control key, drag it down. And if we right mouse into different space, you can see geometry. We have the handles control also exposed in this particular tool, which are available over here. And a very straightforward state. And when you like that, you stamp that with A, and then you can keep on dragging and dropping your different areas. And you can even manipulate this handle to drive it in, and again control to drag down to sort of see where you're going. So, and there you go, and then A to stamp that shape again. So box cutter. Now let's take a look where these things are defined. If I right mouse on here, and if I go into the type properties for this particular asset, and we go into interactive, we can see here there's a viewer state that's defined on the node itself. Many of the default nodes that ship with Houdini will have the viewer state defined in a Python module in the installation build. But in the particular case with the labs tools, it's, the state is actually right in the viewport. And there's ways of creating these blank state, creating new states as well. And you can define how they sit in the shelf tool. There's the handles section now, which is new for Houdini 18, and you can actually create any handles you want, or you can actually, and all these handles available to us are installed inside of Houdini, and you can create your own handles as well. And that's the whole idea now. You can write your own handles and work with them interactively this way, and then bind them into your viewer state. So let's take a look at where those lie. I'm going to open up a new pane down at the bottom. I'm in technical. If you're in build, just either split your viewport pane or hijack one of the other panes. And if I press the plus button here, go to view new pane tab type, if I go into inspectors, we have the viewer state browser, which was available to us in Houdini 18 and has been expanded a bit. But we actually have the new pane tab, also called the viewer handle browser. And under file, we can actually create new handles. We can open a file of handles on disk. We can load a handle, and we can reload all the handles in case they've changed on disk. If we're doing edits on disk, we can force reload all the handles as well. And we can even debug the handles as well. There's filters on here for the types of handles. Some handles are generic to all states. But most are defined for specific states. We can see all the states that are related to the SOP, and there's the move tool handle, and there's a viewer state handle, and all those other handles. So let's pause for a bit, fire up Houdini, and actually take a look at a couple of the example files that ship with Houdini. So in the slide, I've listed a couple examples that we ship with Houdini. One of them is in packages in $HFS, which is an environment variable for the default Houdini scene, viewer handle demo, scenes, viewer handle demo. So I'm going to cut this string and I'm going to paste it inside of my Houdini scene. But we're going to actually take a look at the move tool. And packages viewer, we'll take a look at the viewer handle and then we'll take a look at the move tool. They're both in demo scenes. And the handle is actually installed in viewer handles move tool handle.py. Again, the handle is separate from Houdini. So let's take a look at the viewer handle intro and then move on from there. So now that we saw inside of this Houdini scene where we can actually see the viewer states and where we can actually install handles that are being used by the viewer state browser, we're now going to open up that scene file that I copied from that string, and let's do the viewer handle intro. And here we can actually see a nice example state where you can actually see what you're doing and how you're working with it. So basically locating and picking things, and this file is fully documented to help you get set up. And again, if we take a look at the viewer handle browser, we can see the view tool being used here, the move handle tool. And the second example file that we ship with would be the move tool. And that also uses the handle. So this is a very basic way of defining your own custom handle that you can then use to bind in any of your tools. And again, full help and examples to help you see how to bind these handles to these tools. If we right mouse on this and so we go in the move tool, if we go upstate, right mouse on this, and we go to the type properties on this. We can see here there's the viewer state, and we can actually see the handle that's being bound and referenced into this particular tool. And then the viewer state is calling that specific handle. Very, very simple example as to how to work with handles. And now we want to take a look at the edit operator type properties again, just to review on the handles. So you can actually open up the type properties, create a handle that you want, and then you can bind the handle off of disk to create it. And then you can reference that handle into your asset. And then finally, you can define your own default state to bind that handle to. And some of the other things that we have available to us as well are drawables. And drawables are available to you in the state as well. And one of the options you can use is a highlighter. For instance, this actually adds a highlighted glow around any of the objects that you have in your scene, whether or not it's active or not. You have that drawable available to you. And that goes along with all the other examples of drawing text in the viewport, giving hints, drawing histograms, and so on and so forth. So very, very powerful set of tools with the viewport states, the new handles that you can create, and also the drawables on the screen. One of the limitations we currently don't have is the ability to actually create handles via geometry, via SOPs yet. So right now you're still writing all of your handles via code at this point in time. Now we want to move on to modeling improvements in Houdini. We have a bunch of new SOPs, a host of modified SOPs, and also some really interesting things to key on our attribute paint and the brush hotkey revamp. So they've been, hotkeys have been revamped in those particular tools, trying to find a standard that frees up the middle mouse button. So for instance, Control Shift left mouse now is what's used to resize brushes and all of our brush type tools. And also we can take a look at some compile SOPs that have been added as the list continues to grow. So all the new SOPs, there's tons and tons of new SOPs available to us. Attribute adjust, float integer, those are pretty interesting because it shows a bit of a different look at how that we deal with attributes, and trying to reduce the reliance on new users to learn Vex just a simple wrangle attributes. Mask by features SOP, path to form SOP, and all the KinEffect SOPs, all the pyro sourcing SOPs that have been added. So a tremendous amount of SOPs have been added to the list. And number 7 leads me to these 3 guys, the attribute adjust integer, attribute adjust float, and attribute adjust vector. Those 3 operators those 3 SOPs are meant to make it easier for artists to work with attributes by type, and then we can provide operations by that type. So let's fire up Houdini and have a look at these 3 SOPs. So let's take a look at Houdini and all the different operators that we have available to create attributes to see how we finally got to the attribute adjust integer, float, and vector. Let's start with a lowly grid, and let's really increase that, and let's wire up all of these different all these different attribute type operators to the grid. Way back, we had this thing called a point SOP. By the way, you can still add that in a text port by just doing the old cd to grid object 1 and then using the op add point. We can actually op add point old, and you can create a point old. That would go all the way back to prisms. And some people would say all you needed was just a point SOP and a grid, and you could animate the world. And one of the common things to do in that world was to add color, and we can actually put in here a rand function, $PT for the point number. And let's add an index to that, plus 1.001. And you can make a comfortable living teaching people how to use the point SOP. It's not very artist friendly, but it gets you there. And so this is the lineage that we needed to run up to. And by the way, if you press the help, you can see a tremendous amount of example files and all the variables that you can use in here. So we progressed to that in the Vex world to the point operator, and it's pretty good, but now you need to know what type of attributes you want to work on. I guess from group, it might use points, it might not. Attribute class, sure points. But you'll notice that as I change the various different attribute types, we're presented with the exact same interface. So now it's on the artist to realize, am I in a point or in a vertex? But anyway, let's add random color. So we do the color, and over here we've sort of added these buggy bumpers around Vex wrangling behind the scenes, so we can actually do random. And you can see rand elm great. Still requires a certain level of understanding. Now for Vex expressions, this is about as hardcore as it gets. So you can do v at cd. Yes, you can omit the v because it's a known known attribute, but hey, I'm putting the v in there. And you can do rand and at pt num. So now you need to remember where pt num comes from. It is a global declared variable. It's not even documented on the attribute wrangle. You actually have to understand where that's coming from in the Vex world as declared attribute. Many times we teach people to put down a VOP wrangle and take a look at the global inputs. But anyway, once we do that, now we got random points. Now attribute create. That was another stab at doing this. So again, CD defaults to black. A lot more options. What class are we working with? Let's put down point, type float. It's a vector, I guess. And the value, so we can actually do a float in here. We can do 3 floats. And so you can actually create you know, what it is that you want to do here, what precision. This one actually now starts to see you can actually declare the precision of the attribute as well, 18, 16, 32, 64. So you can now, and the value in here, again, you can use that same rand at pt num, but at least this time you don't need to declare it. And let's add an offset 1.001. And you'd argue that we're right back to where we were with the points up in terms of teachability. Yeah, it's is it getting any better and any worse? No, artists still needed to learn an awful lot about how to do that. And we can see it's not a float. You have to do a vector to see the color. And then we added attribute randomize, which was, again, what do you want to work on? Points CD. It defaults to CD, yay. And now you can choose what type of noise you want to do. Again, let's do constant value, not random. Let's do 2 values. Let's do uniform discrete. And now you can change, at least you can change the minimum and maximum range now. Again, loose collection of where to go. And of course, attribute noise, a dedicated operator for simply adding noise again. And you know, you can actually add animation to this. So you can scrub and you can see your noise animated. And then there's finally attribute remap, which allows us to, it doesn't even show us the attribute. So it's CD, we know that. and the original name, and let's wire that into there. And now we can remap these ranges again. So we got some of the functionality that we got with the attribute randomize, and we can actually apply a ramp to this, and we can actually do some really cool thresholding. So all attempts at trying to minimize the amount of work that an artist needs to do. So what did we do? We have the attribute adjust integer, attribute adjust float, and attribute adjust vector. So another stab at this whole world of attributes. So we have attribute adjust integer, and the attribute name, we can use CD, we can pick on CD, or we can use variant, and we actually have a nice visualizer now. So all the modern trappings that we have in SOPs available to us in 18.5. And we can choose what class, point, vertex, primitive, or detail, but the attribute adjust integer, it's really only creating integer attributes. So let's actually take a look at what it is that we're working with. So we go into the spreadsheet, and we can see variant. To be honest, all attributes on point attributes are of type float at the end of the day, but they can have signatures of int to optimize them through the SOPs. And then we can now do random. So now all the options available to us in integer are finally presented in a single interface. So hopefully these are your one-stop attribute mucking operators. So all of this whole lineage and all of the whole mix of assets and attributes that we have, that we've created over the years, hopefully will be replated entirely by these three. So if you're a new artist into Houdini, or you're an existing TD wanted to teach new artists, stick to these three. They're great tours of how to do work, and then show them wrangling if they even want to use it, because you can go so far with how far you can go with this. So you can actually do positive values, you can create amplitude ramps, you can do custom elements to change the seeds, you can even enable post-processing where you can actually blend attributes in and out, you can change the length scale, all kinds of different ways of working on these attributes. And attribute adjust float, again, in this case we're doing it on p-scale. We can visualize the p-scale in the viewport. It's a constant value. We can change that constant value from 0 to 1. We can also randomize this, and again, like we saw before, we can threshold the value. Let's leave it, let's say we were scattering some trees on there, we want a value of 3. This adaptive visualizer will adapt to full range for us if we wanted to. And the step size, we can even apply stepping to this, so thresholding on the attribute, which is really cool. And again, post-process, we can change the minimum and the maximum value of all of this, so we can threshold this away as well. So lots of control in the attribute adjust float. And of course, we always have, you still have to teach new users how to use the control key, or to right mouse on the operator to actually get the, or middle mouse on it to get that, or the control key, or to use the halo rings if you want to wait for the halo to show up. You can actually see show modifications to attributes. So we did a tremendous amount of work trying to simplify this for the artist as well, including getting draw visualizers right from here as well. So you can actually use the visualizers right from the attributes. And finally, to complete this attribute adjust vector. So we were picking on V, but let's, and the one thing that's interesting about attribute adjust vector is it isn't the best with color, and we know that. It came out in testing. So we might actually have one specific just for color, or the color SOP could see a rework. And actually, that's one that I should have added as a way of, and let's shift hold down that and drag a copy wire to the color. We could have done that, but again, this one needs a rewrite because you're stuck with the color, having to wire it into one of these guys again to get it to work. So we know we got a bit more work to do on the attribute adjust vector, but in this case we're doing velocities, and now it's specifically designed to do all kinds of fanning operations on vectors themselves, directions and lengths. We can do random, we can add just noise, we can adjust the amplitude, again the element size for the actual noise itself, we can lower that down if we want to create nice wavy noise through our field. We can apply warping. So specific tools, cutting edge tools for dealing with vertices are now available to that. So to recap, teaching new users or yourself, if you just want to start mucking with attributes and not have to worry about any of it, best of breed, attribute adjust integer, attribute adjust float, and attribute adjust vector. And color, yeah, we'll see. And so that's a great recap on that. And to complete the whole presentation, we have compile SOPs that are added as we continue to take more and more SOPs and we verify them so they can be used in compile blocks. Solaris has seen a lot of improvements. I definitely want to do a separate video on all the power that we have with VexArray and support and Wrangle LOPs and VOPs. Tremendous amount of control. Finally have arrays. And that's extraordinarily fast now. So we can actually pack attributes into arrays and do some really heavy lifting in Vex. USD dynamic payloads. My gosh, we finally have USD supporting digital assets, and we actually have the HDA dynamic payload LOP where you can reference an HDA. It's ideally suited for hair and fur, but there's an example where you can even just generate spheres at render time. And it's a way of getting geometry into the render engine as a payload. And yes, it will use an engine license for certain amounts of geometry creation. And command line rendering, definitely want to cover that one as well. We can now offer Python commands for doing last-minute injection of USD into Husk command line rendering. For instance, turn all objects that contain pig heads or whatever you want can be easily added at the command line when you're rendering via Husk now. And KinFX, which you're probably going to see lots of. I definitely want to have my own take on that. Dynamics, as we saw before, looking at all the atomic SOPs that we have, and finally the PDG. Definitely want to have a look at all the improvements inside of the PDG, including some things that are outside of that, including the data layer, partition attribute improvements, work item generation parameter, a lot of housekeeping work and a lot more sophistication in the cooking and PDG graphs now. And finally, there's the web server module. Definitely check this out. It's worth seeing how you can embed Houdini commands inside of a web server, and then you can feed that into any Houdini request, any running Houdini process. Very, very powerful stuff. So thank you very much for hanging on for this quick tour of Houdini 18.5. Enjoy all the features. It's a deep, deep release with a lot of meaningful tools and with a lot of thought moving forward as to how we're going to deal with interactive tools and the artists, as well as keeping the high-end TDs happy. Thank you very much. Bye.